Hello, let's work on this system of inequalities. We have here two inequalities that have one variable, just one variable, the same in both, and they are first degree inequalities. So what we have to do is we have to find values for x so that satisfy both equations at the same time. So I'm going to solve every inequality individually, and then I'll try to find the values of x that satisfy both at the same time. So let's get rid of denominators. First thing I'm going to do is find common denominator for both, and once I have the same denominator here and here, I multiply by the same denominator so they will disappear. Remember that in inequalities, I can do transformations in both sides. I can add a number on both sides, I can subtract, but you have to be careful because when you multiply or divide by a negative number, you have to change the direction of the sign. So, common denominator here would be 4, and the second will be 6. So, I leave this how it is because I already have the same denominator. Here I would have 2x, then here I would have 12. In this case, 6 divided by 3 equals 2. 2 times 8, 16, minus 2x. And here, it would be 3 plus 3x minus 6. Now, let's multiply this whole inequality by 4, and I would have this. 2x minus 12, and here I multiply both sides by 6, and the denominators disappear. Alright, let's organize a little bit. Variables to one side and numbers to the other. So this comes here subtracting. I will have minus x is less than negative 12 minus 2, negative 14. And here you have negative 2x minus 3x minus 5x is less than 3 minus 6 minus 3 minus 3 minus 16 minus 19. Now to make this variable positive, I multiply both sides by negative 1. And as I told you before, when you do this, you have to change the direction of the sign. So instead of being less than, now it is greater than. And here, to isolate x, I need to divide by a negative number, in this case negative 5. So again, I have to change the direction of the sign. And here 19 over 5, because a negative over a negative is a positive. So let's see. Following this inequality, my variable must be greater than 14. Let's say that 14 is here. So my variable cannot be 14, right? Because it is just greater than, not greater or equal to. So I drew a circle without coloring it, and numbers that are greater than 14 are to the right. So to follow this inequality, my x values must be here. And to follow this one, 19 over 5 is to the left of this value. And since it has to be greater, again a dot to the right, okay? And to satisfy both things at the same time, it has to be from 14 to the right. So my solution to this system is this. And I can write this as well. The whole solution for both would be this. This is the solution that satisfies both inequalities at the same time. Must belong to the interval from 14 till infinite. 14 is not included because it is not greater than or equal to, just greater. And 14 is not greater than 14. This is not true. So this is the end. I hope you understand. Bye. See you soon.